Good morning. Today we're going to run through a sample using the Beckman LS13320 laser diffraction particle size analyzer. This is the computer that houses the software for operation. This is the laser analyzer. In a previous lecture, I did show you inside of this door, and this door is to remain closed while performing the operation. Here is the reservoir tank it's connected to. This is where the sample will be loaded into. So we are going to go ahead and start the program. We're going to choose run and run cycle. Since this is the first sample, we are going to choose all of the options. So we're going to start with an auto rinse that will clean the reservoir tank. It'll then automatically move through all of these steps. We'll be pausing because some of the steps do take a little bit of time. So we'll go ahead and start now. So we're performing an auto rinse. Cleans the tank to ensure that the obscuration of the water is down around 0. It may dip into the negative values, but it won't go very far into the negative values. And here we can see the water is being sonicated. The water level will raise and lower during the process. I'm going to pause it here because this typically takes about 3 to 5 minutes to complete. So I'll pick it back up when this is complete. Alright, we are completing the auto rinse. So it's going to automatically move into measuring the offsets. And these are all calibration steps to ensure that there is no background interference when the sample is actually run. Couple of things to address while this is performing. Over here at the sink, there's a nozzle labeled DI for deionized water. We ensure that that is turned on prior to starting the machine, and after we're done running samples and we shut everything down, we shut it off. And this is the centrifuge that we use. When the samples have completed digesting the organic matter, we would put them in there, ensure that they are positioned so that there wouldn't be a misalignment for when the centrifuge is running. And we use that to kind of draw down all of the sediment sample to the bottom so that we could pour off a majority of the water that remains. Right now the machine is now going to align the laser to ensure that it's pointing in the proper direction. It's typically done in less than a minute. And in this case, it was 51 seconds. So now we're measuring the background. This allows the program to ensure that there is no background interference, and if there is any that remains, it would be able to make the adjustments when it comes time to analyze the grain size. At this point, it's a good time to use a vortex mixer. We want to ensure that what water does remain, and again it's DI water, so we want to ensure what water does remain becomes a hyper solution. So we'll use this. And don't just keep it in a vertical. You want to kind of agitate it really good so that it becomes a hyper solution. And at this point, it's now measuring the loading and the obscuration. We want that number to fall between 8 and 11%. And so we'll come here. We'll add a little bit of the sample. We're still just under the desired amount. So we'll come back, add just a little bit more. That should do it. All right. So from there, we'll start analysis. Going to pop up a new window for us so that we can label the sample. And we're going to go for this sample, the name of the class, the operator. We're just going to label it test and run number 1. So we'll click OK. Here we ensure that the export data is clicked. That'll give us an Excel spreadsheet format of the data, and we also ensure that the file destination is updated as well. So we'll click OK. It's going to start running. Produces a histogram as it's reading the measurements. And here we can see majority is lying between 2 and 60 microns. So this would be a silt sized sample. And after that, it's going to go ahead and through another auto rinse, clean out the reservoir tank. And that's how you run a sample on the Beckman LS 13320. Thank you.